Hello and welcome to this session. Today we're going to talk about how to test and train your robots with AWS RoboMaker. My name is PD Datta. I'm a Senior Product Manager in AWS RoboMaker. And later you will hear from Martin Lofru Alonso, Senior Robotics Scientist at Irobot, on how they use RoboMaker to scale their testing in simulation. Here's what the next 30 minutes are going to look like. We're going to start by talking about robotics development lifecycle and some challenges that robotics face today. We will then discuss how simulation can help alleviate those pain points. Then we will talk about an overview of AWS RoboMaker Simulation. And then finally, we will do a deep dive into the different customer use cases. So let's start with what's a robot. When I say a robot, some of you might be thinking about a humanoid robot, some of you might be thinking about a vacuum cleaner like the Roomba, and some of you might be thinking about robotic arms. We take a very broad view of what defines a robot. For us, a robot is any autonomous machine that is capable of sensing the environment, that can perform computations, make decisions, and then ultimately take an action in the real world. To give you a general idea, robotics follows the same processes as the well-established software development lifecycle. You start with a software framework, you develop the application, you test and train the application, and then you deploy that application onto the robot. Now here you'll see that step 2 and 3 in robotics takes a lot of time. You need to iterate a lot. Now what's different in robotics is not every developer working on that application has access to the physical hardware. Because one, it could be extremely costly. And two, typically what you're prototyping is not what goes into production. However, we see customers doing robotics development with testing physical robots, and they have these following challenges. So first, you need to have expertise in different domains. You need to have knowledge about hardware, security, deployment, testing, networking, etc., which is time consuming because you spend most of your time fixing issues than actually working on your application, which is your core competency. Now in robotics, you have to constantly iterate to get something right. And with limited hardware, it becomes very difficult. It slows down your development cycles. And to iterate, you need to deploy that application onto the robot, which has another set of physical steps. Plus, it's not possible to scale your tests with different scenarios with physical robots. So you're probably noticing a theme here. While you can get started with building and testing your applications with physical robots, it's a very short-term solution. This will not scale. It's not sustainable in the long term. So this is where simulation comes in. Simulation is an attempt to model a real life or a hypothetical situation on a computer and see how the system behaves. So you have the 3D world or the 3D scene with physics built in. You have the virtual robot described in it with its sensors. You have GUI tools to visualize what's going on in simulation. And then you have interfaces to interact with the robot or virtually investigate the behavior of the robot. You can also make predictions about the behavior of the system by changing the variables in simulation. Plus, you can run it on the cloud where you don't have to manage the infrastructure. By testing in the simulated ecosystem, customers can iterate on designs quickly, fine-tune their robotics applications before they actually deploy it to physical hardware or physical robots. So in other words, simulation is the best possible substitute for physical robots. Now, the two most prevalent use cases for simulation is testing and training. You can test multiple scenarios and make your robots more robust. And you can also provide randomized environments to train your robots to make them behave more accurately in the real world. To understand the benefits of simulation, let's start with an example. On the left-hand side, you have a bookstore. So say you own a bookstore and you have robots cleaning the bookstore, or you have robots going through the different aisles and doing an inventory of the books. And you also have humans working in the same bookstore. Testing this human-robot interaction is super important, and you can do that safely with simulation. Let's take another example. Say you're an online retailer with warehouses across the country. You have robots transporting packages from point A to point B on those warehouses. And you have a skylight through which sunlight comes in, reflects off of the floor, and then makes the perception stack on the robot behave in an unexpected way. While this might seem like an edge case, such things happen all the time, and it's difficult to reproduce with physical robots. But with simulation, you can repeatedly run these scenarios, you can create tests around it, run the regression tests, so that your robots are trained and it doesn't behave in an unexpected way when it encounters this situation in the future. Third, you can speed up the clock. So you can run simulations faster than real time, which means you can get results in a fraction of the time than it would take when you are testing with physical robots. Fourth, you can expand test coverage by programmatically testing a wide range of scenarios using parameterized and repeatable simulations. Now, this will ensure that when you take a robot and put it in a new warehouse or a new environment, it immediately starts working as it's supposed to. Validating your application in simulation before developing the robot or deploying the robot application on the robot shortens your iteration cycles, and then it identifies potential issues much early in the cycle. Finally, you can dedicate a virtual robot or a virtual environment in simulation to every developer, which reduces your cost significantly. So overall, simulation helps you increase your development and testing velocity and helps you improve your code quality. So at this point, we've determined that simulation can be beneficial in multiple places in your development workflows. It can provide a faster pace of innovation. But there are some key challenges and blockers for customers to get started with simulation. Here are some of the common ones we've heard from customers. First, you need to set up the infrastructure, which can be hard to configure, standardize, and scale across multiple development environments. This is particularly challenging if your simulation is communicating with an external application or control system, or you have complex networking configurations. It is hard to get consistency across developers' local environments and create an easy way to automate all of those workflows. And finally, creating 3D models, be it the virtual representation of the robot or 3D worlds with assets in it, it's hard, it's difficult. Even with good tools and excellent artists, there's never going to be enough handcrafted worlds that can help you scale your simulation and testing. Now, AWS RoboMaker brings cloud scale to simulations. There are 4 reasons why customers use AWS RoboMaker. First, it provides a managed solution which enables you to run your simulations consistently and reliably. If you think about the first step of the development lifecycle, choosing the right software framework is super important. Now, Robot Operating System, or ROS, is the most widely used open source software framework for robotics development. And that is why we chose ROS. ROS is actually not an operating system. It's a middleware that handles message passing through a publish-subscribe model. It provides standard formats for robot descriptions, messages, and data types that are used by thousands of roboticists across the world for a variety of use cases. It also has a vibrant user community which contributes multiple open source packages for common functionalities. Robomaker uses the open source Gazebo simulator. It's a physics-based simulator. And Robomaker supports ROS1 kinetic, ROS1 melodic, ROS2 dashing, with Gazebo 9 and Gazebo 7 based applications. So you get the benefits of managed ROS and Gazebo built in. So that'll free up your engineering resources. You can also visualize and interact with the robot in simulation through the open source GUI tools that you can stream through the Robomaker console, such as Gazebo, RViz, and RQT. Or you can bundle your own tool and then stream it through the Robomaker console. Robomaker provides health checks and then manage ROS nodes to cancel a simulation job or tag a simulation job that you can use as convenient functions. Robomaker also allows you to collect simulation data, such as ROS logs, Gazebo logs, and ROS bags, that gets uploaded to your Amazon S3 bucket location of your choice that you can use for future analysis and replay. So second, Robomaker provides a single API, the Robomaker Batch API, to run concurrent or hundreds of concurrent simulations. Third, with the pay-as-you-go pricing, you're only paying for the simulation resources that you use. And it's measured at a minute's granularity. Finally, WorldForge or Robomaker WorldForge enables you to generate randomized 3D worlds with different floor layouts and furniture configurations. Now, when we were building Robomaker, we heard from customers that managing or setting up the infrastructure was their biggest pain point. And that's why we launched Robomaker with a managed simulation service. As customers started using Robomaker, they shared that creating 3D worlds to scale their testing is their next biggest pain point. And that's why we built Robomaker WorldForge. Now, to create worlds in WorldForge, you start with a template that is JSON based. The Robomaker console has an interactive template editor. So you can go to the console and either choose from the sample templates that Robomaker provide, or you can create your own by customizing and creating a template from scratch. WorldForge provides 3D assets out of the box, such as tables, chairs, beds, fridge, etc. And then WorldForge will randomize the floor layouts, the furniture density, and the texture of the walls and the floors, and then will enable you to generate one or hundreds of worlds within minutes, which could take you weeks or months if you were to hire a 3D artist to do it yourself. Now, WorldForge has additional logic to ensure that the floor plan layout, the connections between two rooms, and the furniture placement mimics the real world. For example, the back of the fridge or the back of the shelf will be placed against the wall, so that the front of the fridge or the shelf is always accessible, as you would find in the real world. Now, it only costs $1.50 to create a world using WorldForge. Again, which could be very expensive if you were hiring 3D artists and just building the world yourself. WorldForge is fully integrated with Robomaker Simulation, which means that all you have to do is bring your code, choose the world that you've created using WorldForge, and get started with Robomaker Simulation. The worlds have physical properties or default physics built in, so you can test the robot interaction as well. And then WorldForge guarantees that the default position in Gazebo, which is the 0, 0, 0, the default starting position, is always clear, which means that you can start your robot in the simulation without worrying about colliding with furniture. And finally, you can generate hundreds of worlds. And as you're generating these worlds, you can tag them with key value pairs. These tags enable or make it easy for you to categorize, identify, and search these worlds when you have hundreds and thousands of worlds. So there is a huge amount of variety that you can generate with WorldForge, and then you can test and train your robots in simulation. So next, we're going to talk about different use cases that customers use with Robomaker for the simulation use cases. So there are 4 use cases that we're going to discuss. We're going to talk about first, automated regression testing in a CI/CD pipeline. Then we're going to talk about multi-robot simulation, followed by reinforcement learning. And then finally, we're going to close with a sandbox use case. Okay. So one of the most common use cases that we've heard from customers who use Robomaker and AWS in simulation is automated regression testing in a CI/CD pipeline. CI, or continuous integration, is where automated build processes and tests are done so that you can prevent integration issues when developers are working in silos. CD, or continuous delivery, is the process of creating ready-to-deploy artifacts, such as a ROS application, so that your team can generate new features and updates and quickly deploy it in customers' platforms. So let's take a look at this architecture diagram and understand how you can build a CI/CD pipeline using AWS and AWS Robomaker. Now, before I go deeper into this architecture diagram, I do want to introduce you to some of the terms and AWS services that I'm going to use. So I'm going to talk about a service called AWS Code Pipeline. It's a service that you can use to trigger and orchestrate the process of creating and managing a pipeline. So when you use it, it's going to get kicked off when we push our code to the integration branch or GitHub or the release candidate branch. And then it's going to orchestrate each of these processes automatically. Another service that we're going to use is AWS Code Build. Now, Code Build takes our software, it builds it, it bundles it, it uploads it to S3, and then it's going to trigger a set of tests in Robomaker. Another term I'm going to use is ColdCon. So ColdCon is a code build tool used in the ROS ecosystem. Now, we built a bundle tool within ColdCon that allows you to package your robot code, your simulation code, and your simulation tools that can easily run inside Robomaker. So if you look at the diagram now, you start with working on your local branch. It could be in the cloud, it could be locally. Basically, it's your branch and you're developing code, you're iterating on it. And then once you're ready, you can merge these code into the integration branch. This will trigger a code pipeline job. Now, this is the CI portion of the pipeline. So the next step, or the third step here, is to run the ColdCon build and bundle commands to create a ROS software bundle. After that is completed, Code Build will upload this bundle into S3. Now, with the latest bundle in S3, the final step here, step 4, is to set up a pipeline where you're triggering off different tests in Robomaker. So if you just look at the red box, I'm using a Lambda function here to trigger a set of tests. You don't have to use Lambda. It's an easy and convenient way to write tests and then trigger them in Robomaker Simulation. You can write your own tests using the AWS CLI or SDK, and then you can use the code pipeline to just trigger these tests. A sample test, for example, could be, say you tell the robot to go from point A to point B. If the robot reaches its goal, which is point B, then the test has passed. If it doesn't, then the test has failed. So say, for example, the tests have passed. So then I will want to merge this into the release candidate, which will go to customers, the release candidate branch. And the next set of steps are similar. Now, this is the CD, or the continuous delivery portion of the pipeline. You're probably running more number of tests, and you're probably running more robust set of tests here, because this release candidate will be ultimately deployed in production. So once all the tests in the CD pipeline has passed, your code is ready, your build is ready, and it is ready to be deployed into production robots. So now let's hear from Martin from Irobot on how Irobot uses AWS Robomaker to scale their CI/CD pipeline.
Hi, I'm Martin. and I work as a senior robotics scientist at Irobot. Before using Robomaker, our testing layout was one in which we had to execute test cases in our local machines without any automation at all. This implied that each developer used his or her own intuition when deciding which test case to execute when trying out a new code change. As our product line grew larger and our code base grew larger too as well, we realized that this did not scale effectively. There is so much between testing at a module level and at a system level that one cannot even imagine. Take, for example, the case of robot kidnaps. We allow our users to pick up the robot while cleaning, place it in a different spot, and continue the cleaning process. This seemingly harmless event executes code paths that are usually not executed at all and are hard to test at a module level. With Robomaker Simulation, what we do is we implement a continuous integration, continuous delivery program in which each test case is executed for every code change that is done by the developers and no longer depending on their intuition or ability to detect potential hazards. With the addition of new products to our portfolio, we realized that the testing burden for developers grew geometrically with the number of products. Developers were soon found in situations in which they would have to learn a new entire platform just to test a small change that affected it indirectly. Moreover, as we migrated our products towards long-life operation, also known as long-term operation, we realized that we needed regression testing for the stability of our system throughout tens and even hundreds of missions in a given environment. Single run success was no longer satisfactory. As with usual code paths, we tested for this at the module level, but it was hard to do it at a system level. With AWS RoboMaker Simulation, we were able to integrate our testing in a continuous integration, continuous delivery workflow. We scaled testing to 100 times what we were doing before, going from 50 tests per day to over 5,000 and counting. Unusual but important use cases like robot kidnap that I mentioned before have counterpart simulation tests that execute those hidden code paths upon every change. Furthermore, the side of changes to all products and platforms can be automatically tested without the developer having to understand the intricacies of each one. Each night, the most recent code is automatically tested 60 times across our different robot models. We use these nightly simulations to screen for regressions of our long-life operation capabilities. Robomaker has decreased our time to develop, and we catch bugs that we have not caught before when we were managing simulations ourselves. With increased testing coverage, I'm confident that each time I make a code update, it will work in production. In addition to that, Robomaker allows us to scale the dimensions of new products and new environments. I can now, for example, test a new product in simulation before it becomes available for us to use. One other challenge we face with simulation testing is creating a variety of simulation worlds that cover the breadth and complexity of scenarios a robot will encounter in the real world. We are excited to begin using AWS Robomaker WorldForge, which make it easy to create hundreds of randomized simulations worlds that mimic real-life conditions without engineering, investing, or managing world generation infrastructures. With WorldForge, we will be able to scale the number of scenarios a robot will encounter and increase the accuracy of our simulation testing. With Robomaker Simulation, we have seen a huge improvement in our code base. On average, we catch one set of tests that fail per day and are able to quickly identify and fix the error before our code base is updated. These are code errors that will have negative downstream impact in our SQA or even worse, our customers. With AWS Robomaker, we have been able to catch these errors early, increasing the quality of our development process, product, and customer experience.
Thank you, Martin, for sharing how Irobot has scaled their automated regression tests using Robomaker. Let's now switch gears and talk about our second use case, multi-robot fleet simulations. Now, we've heard from a number of customers that it is difficult to test orchestration and navigation of a fleet of robots. For example, when you have multiple robots working in the same environment or operating in the same environment, relying on physical robot testing requires a lot of logistics work, and that is required even before you begin testing these robots. And then apart from verifying robot navigation, you probably want to collect data from multiple robots running at the same time in the same environment. We've heard that customers want to use machine learning to train the robots to react to each other in the same environment. And they also want to develop algorithms that use the state data of the robot. The video on the left shows how you can use networking in the cloud to establish a communication layer between concurrent running simulations and then consolidate the robots in a single fleet simulation in Robomaker. Now, simulation can help in these use cases, in these scenarios, but it can be challenging to set up simulation for multiple robots. This is because Gazebo simulations are usually done on premises, and then you require expertise or expert knowledge to manage the namespaces or compute limits. This is where AWS RoboMaker can help you build a fleet of simulations or robot simulations at scale. You can run many simulation jobs concurrently in the same virtual private network, which is the green box that you see here. It launches multiple Gazebo instances in parallel. So you launch multiple robots, each in its own simulation, and then they can interact with each other. So these are the square boxes that you see, the red square boxes that you see in the diagram. You can also add functionality to the robot application to help its sensors see other robots in the shared environment using Gazebo plugins. Bastion Solutions is a great example who used AWS RoboMaker to run a fleet of 35 plus robots in simulation to test navigation, orchestration, and inter-robot interaction. All right, let's move to a third use case, which is reinforcement learning. Now, robotics often involves training complex sequences of behaviors. For example, let's consider a robot that is designed to follow or track an object. Although this goal is easy to describe, like the closer the robot is to the object, the better it is, creating a logic that accomplishes this task is much more difficult. Reinforcement learning, or RL, is an emerging machine learning technique that helps you develop these solutions to make or solve these problems. And you can run these RL models with multiple scenarios in simulation to train your robot so that it can achieve the goal in the most optimal way. So in reinforcement learning, the training has two components. One, there is an agent which decides which actions the robot should take. And two, there is the environment, which combines the action with the robot's dynamics and the physics of the world to determine the robot's next step. So in a nutshell, the agent uses a model to decide on an action. For the robot's current state, the model maps possible actions to guesses of how good each action might be. Now, in reinforcement learning, this is known as a reward. So you're trying to basically maximize the rewards and then minimize the punishment. So initially, the model has no idea what actions are best, and its guesses are usually wrong. As the agent learns to maximize the potential rewards it can receive, the model improves, and its guesses about which actions are good also improves. AWS Deep Racer is a great example where customers are maximizing rewards to generate the fastest path for the Deep Racer car to win a race. And Deep Racer uses Robomaker Simulation in the background to train this RL model in simulation. The final use case is the Sandbox Use Case. This is where customers are building non-robotic applications such as Android applications or fleet managers. And users who build these applications are not roboticists. but their apps are ultimately deployed as skills on the customer platform or on the robot hardware. So the ultimate goal here is to quickly iterate and build these applications and accelerate the development lifecycle. With Robomaker Simulation in the loop, customers can now connect their applications to a live virtual robot, perform end-to-end testing of their applications, and improve their development velocity. The biggest value proposition that Robomaker brings to these customers are the GUI tools, which with it can see what's going on in simulation and interact with the robot, and also the ease of setting up this infrastructure, this virtual robot simulation. If you look at the image here, there is a picture in the background where the customer has created a world using Robomaker WorldForge of a residential home. And in the foreground, in front, you have an app that has connected to this WorldForge world. So through the app, you are actually connected to a live robot simulation. Now, if I had to put an architecture diagram to show you what happens, you have a set of developers, they have their AWS accounts, and they're building different software or different applications in the software stack. Using Robomaker's port forwarding capability, and by knowing the IP of the simulation job, developers can connect and view the simulation from their own development machines without having to install ROS or Gazebo. So you can see that developers are really focusing on building the application and not spending time in setting up infrastructure. Now, before I close, let's take a look at a few more use cases where customers are using AWS RoboMaker Simulation. Milvus Robotics implemented a CI pipeline using Robomaker and can now easily test robots in different environments, resulting in huge quality improvement. JetBrains is a startup based in Singapore and India that builds robots which makes hospitals smarter. Now, they were able to successfully set up regression tests in Robomaker, and they're using the open source hospital world that AWS built. One of the tests they run is a navigation test where the robot can autonomously maneuver a narrow corridor in the hospitals. AWS RoboMaker helps Cheetah enable their customers to build applications for Cheetah robots and test them in simulation before deploying to the robot's hardware. So to recap, today we discussed how simulation can alleviate pain points you might face when building your applications with physical robots. We talked about the different simulation benefits, and we talked about 4 different use cases where you can use AWS RoboMaker to test and train your robots to ultimately increase your feature velocity and improve your code quality. Thank you for coming to this session. We really appreciate your time. Please don't forget to complete the session survey. Thank you.